All right, let's dive into one of the most useful tools you'll find in Precalculus and beyond, the dot product. It's a special way of multiplying vectors that tells us a whole lot about how they relate to each other. So let's get right into it. So you know how to add vectors, right? And subtract them. But what about multiplying them? It's not quite what you'd expect. The big question we're going to answer today is how can we use multiplication to figure out the exact angle between two vectors? And the answer to that question is something called the dot product. Now, the very first thing you need to get is that when you dot two vectors, you don't get another vector. Nope. You get a single number, what we call a scalar. And this one number is packed with information, telling us how much those two vectors are pointing in the same direction. Okay, so the dot product kind of has two personalities. On the one hand, you've got the algebraic way of looking at it. This is the how-to. You just multiply the matching components and then add them up. Super simple. But on the other hand, you have the geometric definition. This tells you why it's so useful. It shows us that the dot product is really just the lengths of the vectors multiplied together times the cosine of the angle between them. And here's the magic. These two things are equal. That connection is what makes the dot product such a powerhouse. So what that number, that scalar, tells you is pretty amazing. All you have to do is look at its sign. If the dot product is positive, it means the vectors are pointing generally in the same direction, so the angle is acute. If it's negative, they're pointing away from each other, and the angle is obtuse. But the most important one, the one you really want to remember, is when the dot product is exactly 0. That means the vectors are perfectly perpendicular. We call that orthogonal. All right, enough theory, right? Let's actually put this into practice and see how it works. We're going to walk through 3 different examples that cover all the bases: calculating a dot product, finding an angle, and testing for that special perpendicular case. First up, let's do a nice, easy calculation. We've got two vectors here, u and v. All we have to do is find their dot product. Let's find that single scalar number. So we're just going to use that algebraic definition we talked about. Step 1, multiply the first components. That's 4 times 2, which gives us 8. Step 2, multiply the second components. That's -3 times 5, which is -15. And for the final step, you just add those two numbers together. And there you have it. 8 plus -15 is -7. So the dot product is -7. And hey, wait a second. Remember what we said about a negative result? It immediately tells us the angle between these vectors is obtuse, bigger than 90 degrees. We know that without even having to find the actual angle. Pretty cool, huh? Okay, for our next trick, let's take it up a notch. This time, we don't just want the dot product. We want to find the exact angle between these two vectors. Now this one has a few steps, but they're all pretty straightforward. First, we need the dot product. That's 1 times 3 plus 2 times 1, which gives us 5. Easy enough. Next, we need the magnitudes, or lengths, of each vector. Remember the Pythagorean theorem? That gives us the square root of 5 for u and the square root of 10 for v. Now we plug everything into that geometric formula. The cosine of our angle is 5 divided by the square root of 5 times the square root of 10. That actually simplifies down really nicely to 1 over the square root of 2. And for our last step, we just have to isolate the angle itself, using inverse cosine. And if you remember your unit circle, the inverse cosine of 1 over the square root of 2 is, of course, 45 degrees. And just like that, we used a little bit of algebra to find a precise geometric angle. That's the power of the dot product right there. For our last example, let's check out that special case I was talking about. We want to know if these two vectors are orthogonal. It's a fancy word, I know, but all it means is, are they perpendicular? Do they form a perfect 90-degree angle? Well, the test for this is super easy. We don't need any magnitudes, no inverse cosines, none of that. All we have to do is calculate the dot product and see what we get. So we multiply the x components, 3 times 4, and we add that to the y components multiplied, which is -2 times 6. That gives us 12 plus -12. And what does that equal? 0! That's the magic number. Because the dot product is 0, the answer is a big definitive yes. These vectors are orthogonal. It's such a quick and powerful test. Okay, now this next part is really important. The dot product is amazing, but there are a few common traps that are super easy to fall into. So let's quickly go over them so you know exactly what to watch out for. This is probably the #1 mistake people make. You have to remember, the dot product of two vectors is always a scalar, a single number. It is not a vector. So if you finish your calculation and you've written down something with angle brackets, you know you've gone wrong somewhere. Okay, mistake number 2. This one is so easy to do when you're finding an angle. You do all the hard work of calculating the dot product and the magnitudes, you divide them, and then you stop. You forget that the formula gives you the cosine of theta, not theta itself. You always have to remember that final step. Take the inverse cosine, or arccos, to find the actual angle.
And finally, this is more of a concept thing. When the dot product is 0, it means the vectors are perpendicular. It tells you about their direction. It absolutely does not mean that one of the vectors has to be the 0 vector. As we saw in our last example, you can have two perfectly good non-zero vectors that are orthogonal.
So at this point, you might be thinking, okay, this is some neat math, but why should I care? When will I ever actually use this? Well, it turns out the dot product is working behind the scenes in some pretty cool places. For instance, have you ever played a modern video game and marveled at how realistic the lighting looks? Well, you're looking at the dot product in action millions of times per second. To figure out how bright a surface should be, the computer is constantly calculating the dot product between the direction of the light source and the direction the surface is facing. It really all boils down to this. When those two vectors line up, when light is hitting a surface head-on, the dot product is as big as it can be, and that spot is super bright. But when the light just grazes the surface, the vectors are perpendicular, the dot product is 0, and that spot is dark. It's an incredibly simple and elegant way to create realistic lighting. So, at its very core, the dot product is really a tool for measuring alignment. It tells us how much two things are pointing in the same direction. And that brings up a really powerful question to leave you with. If we can use this little math tool to measure alignment between directions, where else could we apply that idea? Think about it. This same concept is used to compare search results, to analyze documents for similar themes, even to find patterns in DNA. The applications are everywhere, and they all start with this one simple idea from Precalculus.